points. Yeah, well, that's good. So you should go to 140. This is the last class. I'm just putting that on for people who view this video later. So check the scores here. So far, only one student has told me about what they've done enough to get an A. And, you know, when I talk to you, I think a lot of you are doing stuff like NCL, Pico CTF, that pen tester lab. Just show me that so I can give you some points. There's people I haven't heard anything from, and they're going to get an F if I don't see some work you've done. So you should do like 3 CTFs to some extent. You don't have to win or anything. You have to make some reasonable progress on 3 of them. And these other practice ones should work. Like you said, an ACL is fine. Anything is good. Just let me see what you've done. And then as long as you've done a reasonable amount of CTF problems, you'll get an A. Next semester, I'm going to have a more formal procedure requiring, now that I've got a pretty good idea what to do. I'm going to have a series of CTFs, and like every week I'll give presentations on a few problems and get students to give presentations. That's my plan. But anyway, this time it's less precise, but I just want to see progress on.
Close the
last part of your student ID. Yeah. So, and of course, if you went to conferences like RSA or B-Sides or something, that's worth extra credit too. And in fact, there's a talk tomorrow, and that's worth 10 points if you want to go to that. Jacob Sender, the security at Yelp. He's coming here to give a guest lecture tomorrow night. So, anyway, I don't want to give any of you bad grades, so let me know what you've been doing so I can give you some points. And if you need more time, let me know. I can give you an incomplete. But several people have just sort of vanished, and they're going to get an F. So check that out. And are there any questions about anything? Well, if you got no specific questions, I'll show you what I've been doing, which is I started at the pen tester lab. I did the white badge, and then I went back and did the essentials, which is like 100 problems, and I did a bunch of them. And then I went back to look at the tutorial for the essentials, and it said, go do these exploit exercises. And so I went and looked at those, and those are really very nice. So I did Nebula. Nebula had about 14 or 15, and I did most of these. There's a few at the top I wasn't very interested in and didn't do them. But then I went to the second level, which is Protostar. There's 3 or 4 levels of this, and I think this is probably what I'll spend most of the semester doing next time, because it's all free and publicly available, which I really like, because then I can record these videos and post them publicly for everybody, because nobody's going to get mad at me for presenting a write-up. There are already write-ups out there. So if you get stuck, you can Google and find other people's blogs, and it's pretty good stuff. So the Protostar was general hacking. This one is exploit development. And so I thought it would be pretty easy. And I had a much harder time than I thought I would on these simple stack ones, because I was making a very simple mistake. So let me just go through the first few of these. That's my plan. I'll demonstrate some of these. So this is a virtual machine. You download it. It's not very big, maybe 100, 200 megs. And then you run this thing called Protostar. And it is a command line only server here. You get an IP address, and then you SSH in with a username user and a password user. So I like that, because now I have a window I can make nice and big so you can see it. So once you've got in, you go to this directory, opt protostar bin, and then you find all the challenges. And just like the previous one, they are all SUID files. So when you run them, they escalate privileges and presumably do something fun. In fact, most of these don't show you a flag or anything. They just tell you you won or something. So I saw stack 0 here. Stack 0 asked for input, and then it says try again. If you ask for put in more input, it says try again. When you put in even more input, it tells you you've changed the variable. And now that's all it's going to tell you. You successfully overflowed into a variable. So I thought that was pretty boring. And I decided to try to exploit this just to get started. I wanted to do a plain stack exploit. And so I decided, I think I used theirs. Yeah. So then I decided I'm not content to just change the modified variable. So how about we really overflow the stack here? So let me see if they actually gave us the source code. And they did. Okay, so here's the source code. So the buffer is 64 bytes. Then they just put another variable here that's 0. And then if it's changed, it prints you changed it, because they didn't even want to get to changing the ESP and taking over the box, I mean the EIP. They just wanted you to see that when you go over 64, you run into here and that changes the variable as the very first step. But I decided to practice exploiting this one, and I learned something useful. My attempt to exploit this thing, I think I put them all on temp. Let's see if I've still got them. Yeah, this is, I put him L0. I had like a bunch of them because I think I had them somewhere else. But anyway, let me go here and let's first fuzz it. So let me just go through this. You can write to the temp variable. That's generally the case. So I'm going to make an exploit in /temp. I'm going to call it S0A for stack level 0, the first attempt. So that's going to be shebang user bin env Python, I think. I think that's what gives me Python, and then print a times 100. So this is the first step of fuzzing. And let's chmod that to make it executable. S0A, and then run it. Okay, so that prints out 100 A's. Now, let's find out what kind of input it wants here. If I run level 0 or stack 0, it wants the input right there at that line. So I could do this. I could do run this and then pipe to stack 0, and then I'll get a segmentation fault. But I don't know how to put that in that format into GDB. There might be some clever way to do it, but what I've gotten in the habit of doing, which works, is to run it and put it in a text file. So I'm going to put that in a file, temp S0A out. And now I can GDB stack 0. And here I can run with input from that file, S0A out. And that will run and give me the seg fault. And now I can see that I get 41, 41, 41, 41. So some of those A's ended up in the EIP, which is what I want. Now I can take over the box. And I thought I'll just make a simple exploit here. So my attempt to make an exploit was this here. This is what held me back for a long time. So I made this, which looked pretty good. Let me put this in and let's talk about it. There, that's a simple exploit. So quit this, nano temp S0B. Okay, and I'm gonna put in, yeah, I'll put it in, okay. Yeah, forget it, I can't be bothered. Just put Python. Okay, so I have 16 bytes of NOP-SLED, which is 90. Then I have an exploit here, which I think opens a dash shell or something, a simple exploit. So I put in the exploit, then I put in enough A's to reach the total length of 80. And then I'm going to put an address here to go to it, which I'll have to find. This is, so let's see if that works. I'm going to have a total of 80 bytes and then something called the EIP. And in fact, to make it easier to spot, I'm not going to use that EIP. I'm just going to put in an EIP of 0123. There. Now I'll be able to easily spot it in hexadecimal because that'll be 30, 31, 32, 33 in hexadecimal. So if I run that, well, I don't need, I Python that. Okay, Python /temp /S0B, it prints, whoa, okay, whoops. I saw some funny faces. I got to have an equal, don't I? All right, good, let's try that. Now if I run that, okay, that's what I want. So this, this script, I used the Metasploit execute command module, and it executes user bin who am I, because I was having great trouble making any of my exploits work. So this just executes one command called who am I. And all right, now if I run that script, I can Python it, and I can put it in temp S0B out. Okay, and now I can GDB stack 0, and I could run, taking input from temp S0B out. And now I do get 0, 1, 2, 3 in the EIP. So to go further, I should disassemble main and see what the code looks like. This is all the code. It's very simple. It prepares the stack, and then it calls getS to bring in the input, and then it tests to see if something has changed, and it prints out the variable changed or the variable didn't change, and then it returns. And what I'm doing, what they expected me to do was just get the right message there, but I'm gone further. I want to actually take over the box with this return. So I put in a shell, and I want to jump to the shell. So I have to put a breakpoint in anywhere along here would do. I usually put it right after the overflow, right here after the gets. That's when data has gone in, which is going to be too big. So I'm going to break at main plus 29. And now I'm going to run it again. Start from the beginning. Now it doesn't crash. It hits the breakpoint. If I look at the registers, I always look at ESP and EBP. So it's going, EBP is all I really care about. It's going to 7B8. Now I examine the stack in hexadecimal, and I remember 7B8 is the end of the stack frame. So that means here, the word starting at 7B8. So this is the next word. This is the EIP. So that's the EIP. Up here is my injected code with a NOP sled, and here's the egg that does it. So I want to jump back and hit the NOP sled. So instead of 0123, I would like to put in this number, BFF 70. So let me try that. And if I now nano this thing right here. Okay, so that's what I would put in. That's why I always have this comment here. Okay, 770 is the value of the address of my NOP sled. So that's what I should put in backwards, BF, FF, F770. Okay, so if I do that, that should take over the box, according to the logic before. And this is what stopped me for a while because it fails, and it fails in an interesting way. So if I put that in there, and now I go in GDB, and now I run with /temp S0B out, I get a seg fault. And I wondered why. And I finally figured out why. And I think we can see it kind of clearly here. If I now disassemble main again, and I find where the gets is, and I main plus 29, so I put a breakpoint here. Okay, and now I run it again. You know, I hit the breakpoint. So the stack goes from 750 to 7B8. And if I look at that, 750 to 7B8 is here. So that's the stack frame. Here's my address. So when I return, it's going to go to 770, which is back in the NOP sled. So then it should slide through the NOP sled and do this. Everything should be fine. So let's find out why it fails. I can just do next I, and I can keep going as it's going through the steps here. Now it's got the message telling me I've changed modified. In a few more, it's going to do the return. Notice the counter on the left, counting up 80420, 80425. Remember, we disassembled it up here. So we're down here, 420, 425. It's going to hit the return at 434. So next I is next instruction. Yeah, next I is next instruction. Next is next command line step if you have the source code. But we don't have the source code. We're going through assembly language. So yeah, so next, this is very handy. You can step through. You don't need to use breakpoints. You can single step if you're not quite sure where you want to break and see what happens. And especially if something's failing, this really helps because I can see where it fails. So when it hits the return here at 434, that's when I supposedly move to where my EIP is sending, and we're nearly there. So there, 434, okay. It gives me has an error here where it cannot address memory. This is because I trapped it to the EBP. See, one thing to mention, I've done a sloppy exploit here, which is the way a lot of mine are. I changed EIP to the right value, but I didn't fix EBP. The value stored here is the stored EBP. And it can't really use a value like that for EBP, so that could cause problems, but that's not actually the problem here. Well, I guess it is. All right. So then I fixed that too, and it still crashed. And I'm not going to bother working through it in more detail, but let me just tell you, what happens is this egg, this code that executes the instruction, it pushes things on the stack. But after I return, here's the stack frame right here. After I do the return instruction, ESP is right here. So when it pushes things on the stack, it puts it here and here and here, and it clobbers this code. This code uses the stack, and it destroys itself. Yes, I trashed my shellcode. I thought it was very strange. I stepped through the shellcode step by step, and when I got to the last instruction, it was different, and it crashed. And I realized what was happening. My stack is colliding with the shellcode, which I put on the stack. So I just need to fix my exploit to not put the shellcode in the same place. I've been putting the shellcode above the EIP, but I could just as well put it below the EIP. And so that's what I did here. Here's the command that makes it the shellcode with who am I. There's the Python file. This junk is all seg faulting. I tried all kinds of, I thought it was Metasploit not working. I tried all these different Metasploit fixes. I spent like a whole day doing this, feeling very stupid. Why can't I do the simplest buffer overflow? Now I finally got to the point. Shellcode is destroying itself by using the stack. So what you have to do is put in a padding. I just put in all this junk. Then I put in a shellcode over here later, after the EIP, not before the EIP. And now when the shellcode here uses the stack, it's pushing back into this stuff. All this stuff could just as well be padding. I'm not going to use it. I go to my EIP and then I add more stuff here, which is not going to get clobbered. So let me show you this one. This one will work. And there it is. So if I go and quit from here and nano/temp/stack0c and put in that junk there, that will work better. So let me Python/temp S0C. Okay, so it prints out a bunch of junk. That's what I wanted to see. I'm going to put it in temp S0C out. Then I'm going to GDB my thing again and disassemble main again because I want to put in the breakpoint. Whoops. Okay, breakpoint after the get, so that would be main plus 29. Now I'm going to run it, taking the data from temp S0C out. And now from 750 to 7B8 is the current stack frame. So 750 to 7B8. So it looks like my exploit has changed EIP to 4141. I seem to be off, so I'll have to subtract 8 from it. But here's the value. Anyway, the point is now I have NOP slide here and shellcode, but I know this shellcode won't work. But I put another copy of the NOP slide and shellcode down here. So if I go to this address, it'll work. So I'm going to try and fix my problems. The first problem is I have too many A's by H. And the second problem is I want to go down to there. So let's fix those problems in my shellcode. Oops, not that. There, okay. So let me first save my, there. This is my desired EIP. Okay, that's what I want to put in the EIP. And here I need 8 bytes less padding for some reason. I don't really know why, but I don't really care. That should fix that. All right. And so let's see, I'm going to put my EIP to BFFF F618. Okay. Let's see how that looks. That might work, or maybe I've made some other mistakes. So I have to run it, and now GDB it, and now put the breakpoint in. I've forgotten again. I think it's plus 21. It is plus 29. Okay, break star main plus 29. Run from temp S0C out. Okay, the stack goes to 7B8, which is here. Okay, so now it's going to jump to BFFF618, which seems wrong. I wanted to go to 7D0. Okay, my exploit is fouled up. I should have put something happened here. I got 618 twice. Let's see what I did wrong. Oh, that's goofy. Oh, I wanted 7D0. I just put the wrong thing in. That'll do it. Okay. F7D0. I just looked at the wrong comment up there. Okay, fair enough. All right, let's try that. So I have to run that and then GDB it. And then break main plus 21, is it? Thank you. And then run from temp S0 C out. And let's see how the stack looks this time. Stack goes to 7B8. 7B8 is here. It's still 618, and there's 7D0. Oh, I'm still off by 4. This is the saved EBP. That is the saved ESP. I need to subtract, I need 4 less 41s. I still have too many. Okay, so let's fix that. 4 less 41s. All right. All right. Break main plus 29. Run. Oops, junk at end of arguments. Oh, I need to have a star there, not a plus. Good. Now I run from temp S0 C out. Okay, let's see how it looks now. The stack goes from 750 to 7B8. 750 to 7B8. There's 7D0, which will jump down here and miss the NUPs. Well, it's taking me a lot of tries. Just 7C0 would be better, all right? Because all those subtracting A's changed the address, and I forgot to account for that. Fine, fine. Such as life. Okay. Okay, so that should be C0. Fine. See if I care. All right. Break main plus 29. Run temp S0C out. 7B8. 7B8 is here. Now it's finally going to jump to 7C0, which will hit the NOPS and hit something that shouldn't self-destruct. Let's just try continuing. And it does execute dash. Okay, which is what I guess this shellcode is supposed to do. I forget which shellcode I used, but it did execute a new program, so I think my shellcode worked. Anyway, that's what I wanted to show you. And there's a few other things here. So I was pleased just to get started, make sure I could do it. I thought this was going to be a little more challenging than it turned out to be, but it gets more interesting if it gets to the later ones. So stack 1, you modify variables. And this one here, you're just seeing how variables are laid out in memory. So you have to modify a variable and hit it so it is 61, 62, 63, 64, which is lowercase a, b, c, d. So let's just, this one you don't even need the debug or anything for. It's stack, is it 2 or 1? 1, okay, stack 1, specify an argument, so, okay. And so you try more, and I think again, it's 64. So if you try this, there'll come a time once you've got 64 of them that you'll see something else happen. Okay, so now, so I got some of those little A's in there, but I need to get A, B, C, D. Okay, so I need to first find out how many of those I need. So let's take some away. Those, okay, take some more away. Okay, so it was those. So let's try 0, 1, 2, 3, 4, 5, 6. Okay, the 0, 1, 2, 3, 4 is what did it, and backwards. So now they wanted me to have A, B, C, D, but instead I got D, C, B, A. I need to reverse the order, that's all. There, now I win. So that's all just showing you what little endian is and how to find a variable. That's why I thought this is pretty, this is like a lot of these free training products, it's very gentle, step by step, and then suddenly you fall off a cliff. This is, so you do that one, this one here, you learn how to set an environment variable, which is kind of a new skill for me. These environment variables, you can set them with set. This shows you all the environment variables that exist. They're in Linux and Windows. These are the permanent environment variables. So if you set an environment variable, it only is used for your current session. If you use env before a variable and then run it, then it is used for that one program you run afterwards. And if you use export, it exports into your shell, and then everything you launch has it in there. So if we look at this one, here's the source code. It's going to look for this thing called greenie. So if you run stack2, it tells you there's no greenie. So you have to set it somehow. And there are various ways to set it. The simplest way to set it is this way. And then run the program. That will export this variable into just this one run of the program. This is something you commonly use for something like a debug flag that turns on a bunch of extra print statements that you don't want to have all the time, but you want to turn it on when you need it. And see now, now I have the variable set, and I'm getting to a different error. So the first thing you have to do is set the variable. Now I'm supposed to hit a buffer of 64 and get 0D0A, 0D0A, which is another difficult thing. It's going to copy the variable into the buffer. So this took me a while to learn. I had to put data here. So again, have to put in a lot of stuff. And it seemed like it was about here. Yep, now I got the 61s in there. So greenie is then copied in the buffer. So now let's just trim this back down. Okay, that's good. There's one more 61 getting in there. So I want to go here, and now I can go 0, 1, 2, 3. Okay, now those characters went in. Now the characters I need to put in there are 0D0A, which is carriage return line feed, carriage return line feed. So I can't just type them. And I didn't know how to use Python to create that, so I Googled for it, and I found out that you can do this in Bash. You can use $quote for literal binary stuff. And then it's like it is in Python. So with $quote, I can now include hexadecimal values here, like 0D, 0A, 0D, 0A. That was news to me. Now I got AD, but I wanted DA because it comes out backwards. So I just need to flip my Ds and As, which I can do this way. And then I win. So again, you're just practicing how to reject things. And I thought this is pretty nice, stuff I went through a lot faster in my class. So here we look at environment variables. And now we're going to overwrite function pointers stored on the stack. So this is, before you overwrite the EIP, which we've already done, he's going to write a program where you set a file pointer equal to 0, and then you call that file pointer. So all we have to do is overflow the buffer into the pointer, and it will use the pointer. This is a simplified situation. Now, there's a win function up here that we want to hit, but it doesn't link the win function anywhere. So you need to find the address of the win function. Now, the way I've been doing it in the exploit development course is with GDB, but you can also do it with objdump. You can do objdump minus D of level stack 3, and pipe it through more, and it will show you all the assembly code. So there's init, here's some links to other, here's start, which is just a shell. There's more and more junk here. Frame dummy, there's main, and there's win. So I'm going to stop it here. This is the address I need. That's where I want to put things. I want to hit win. So you can do it with trial and error now, as long as you save that number somewhere. So let me just go here, and I'm going to, I'll just go to the end. Demo level 3. Is this level 3 or level 4? It is stack 3. Okay, stack 3. I just need to remember that number there. Well, that's what I want to hit. I want to hit that win function. I'm just going to make it big so it's visible. Okay. Okay. So now I've got that available. I'm going to shove it down there so it stays on the screen. Okay, now let's run stack 3 and see what it, okay, what's the input here? Okay. Let's put in a bunch of A's. Okay, that hit the 6161s. So I'm going to put this in the clipboard so I can modify it. Let's try a few less. Okay, that didn't hit any. All right, so I want to add something to that. Okay, 3, 4, 5, 6 is what hit. So I want this plus the next 4 go in, let's call it A, B, C, D there. That should go in the EIP, and it does, backwards, okay? And the place I want to go is here. So I need this backwards, and I don't know how to do this in the command line without it being kind of annoying. You can use Perl -C or Python -C, but I prefer to just write a file. So let's nano this. Temp, this is stack3a, and now it's going to be pad equals there, and EIP equals this thing backwards, which is 24. I'm reading from the bottom of the screen, 84, 04, 08. And so I print pad plus EIP. That should create the string I need, which I cannot copy and paste because it contains unprintable characters. But if I Python temp S3A, it prints out the junk I need with unprintable characters. And if I pipe that into stack3, it worked. It hit the right value. The 08 and 04 are the unprintable characters. And some of the others, the question mark is something else funny. So that's why you can't copy and paste it easily. You need to somehow tell it to print it in raw binary. And so I like to use a separate Python script to do it, but you can do Python in the command line with like Python -C print 1. I think you can do stuff like that. Yeah. So you could do Python -C print. You need 2 levels of quotes and stuff. And there are some old exploit books like Gray Hat Hacking that do it all with Perl, inline Perl. And I've found that to be more confusing than just having a separate file for me. But that's probably because I'm used to old days of Fortran programming. Writing a program seems like a natural way to solve a problem to me. And I'd like to have the program in its own file so I can put the output, see how long it is, and debug it, and then take the output and put it in the other file. All right, so number 4, you look at saved EIP and standard buffer overflows. So this is the one that essentially duplicates what we've already done. You have a buffer, you get the buffer, and you want to go up there. So all you have to do is control the EIP. So again, it's very easy. You don't even need a debugger. The only thing you need is GDB or objdump to find where win is. In fact, let's try being a little clever about this one. Stack 4. If I run stack 4, it asks me for stuff. Okay. Now, if I objdump minus D stack 4, I know I'm going to get page after page of output, so I'm just going to grep it and look for win. There we are. Now I get the number I want. That is the address of win. So let's put that here. And I'm just going to label it so I'm not as confused if I ever look at this again. Okay, that's the address I want to hit. So now I don't even need a debugger again. I can do stack 4, and I can take this one here. I bet it's the same. But now it doesn't tell me anything, which is disturbing. Let's go back here and look. It was a buffer of 64. Oh, I remember this. Let's do it in GDB. It's easy to see in GDB. If I GDB stack 4, and then I run it. First, let's do disassemble main, put in a breakpoint. Okay, so here's the function. Here it does gets, then it's going to return. So let's put a break at main plus 21. So it doesn't try to return, but it does do the overflow. Now I'm going to run it. I'm going to put in the string that worked before. This put ABCD in the pointer that was used. And now if I input register, ESP to EBP goes to B8. And so B8 is here. Here's the little A's I put in. here's the start of the 1, 2 stuff. Here's the ABCD I put in, and notice it's off by 12. That's because there are other objects saved. There's the stored EBP and other things at the end of this. So before I had the 64 bytes reserved, and the very next 4 bytes were used by the pointer, which was pointed to called FP. Now I'm going to have to hit the real stored EIP over here, and that's 12 bytes further along because there is some overhead at the top of the stack. So I have to move over by 12. So let's go here and run it again. Put in the stuff that worked, and now inject 12 more before it. So the ABCD is there. I want to put in, that's 4. So I 1, 2, 3, 4, 1, 2, 3, 4, and now ABCD. That should do it. That should now go to ABCD at the end of that. I'm going to put that in a clipboard because I think it's right. And let's do info registers. The stack ends at 7B8. Oops, I missed the 0. Okay, 7B8 is here, and now it's going to go to 1, 2, 3, 4 if I continue. So that's what I want. Okay, so now I know the string that gives me control of the stack. Now I need to find the address to attack. I've got it down here. So now I know how to make this. I can, let's just nano/temp. And which one is this? Stack 4, okay. So stack 4A, and it's print, let's have pad equals there. That was the thing that worked. The ABCD was the EIP. So EIP is, okay, it's that junk backwards, F4, reading from the bottom of the screen, 83, 0408, and then print pad plus EIP. That should do it. Let's see if it does. So Python/temp S4A prints out that junk, okay. And if I pipe that into level 4, it's not level 4, it's stack 4. I win. Code flow successfully changed, and then it crashes. Because remember, I jumped to the win function, but when I tried to return from that, I hadn't really rearranged the whole stack to survive another return. I've corrupted it. So this is, by the way, is why a lot of Metasploit modules have options to fork before and use a funny exit at the end in case you fouled everything up. So your new process can be clean and then let the old one crash because you don't care anymore. All right, so that's level 4. And let's take a look at level 5, stack 5. So this is a standard buffer overflow. Now you have a chance to put in shellcode. At first, I used to suffer trying to fit shellcode in 64 bytes, but now that I've learned better, even if you do fit it in 64 bytes, you're still hosed because it's going to use that stack and overwrite it. So now I just put it later, and there's no real limit. Not until you hit the end of the memory segment. So now I can put a nice big shellcode. So, by the way, I should mention I had a problem with Metasploit. I tried to use Metasploit to generate my shellcode, and I kept getting Android errors, crashes, MSF payload would crash. And I found some blogs about it. What's that? What? No, it wasn't that it expands. It's the actual MSF payload crashes, errors in the Ruby code. And the reason why this happens is because I'm running on 32-bit calling. And the Metasploit team doesn't care much, and they don't keep the 32-bit very updated. So there are some workarounds. You can sometimes delete the Android part of the thing and it works. Sometimes you can change some variables and it'll work. I updated to the very latest version, and that made it work. But in general, when it irritates you, you just use 64-bit because they don't really care much about the 32-bit version of Metasploit anymore. That was the impression I got. I found people complaining for this back in January, and they pretty much got that answer from the team, oh, who quit using 32-bit? Who cares about that anyway? 32-bit is on the way out, and you could generate your shellcode on 64-bit. Anyway, so this is stack 5, and that one was pretty easy. I think I'm not going to go through it much. Here's what I did. I put in, yeah, this is one that worked, where I put in the prefix EIP and obsolete buffer on the other side. So just 32 bytes in that. So it's pretty simple. It's close enough to what we've already done. I'm going to jump ahead to stack 6 because here I had to learn a whole different technique. And one I heard about, and it did not put in the exploit development class this semester, but it's worth seeing. So here's the problem. We got the same old thing, a 64-bit buffer, a chance to overrun it, and then we can go and try to hit some variable saying you got a certain path. But they're not going to let you jump to addresses that start with BF. If the address you're jumping to starts with BF in hex, it's going to just print this message and quit. So you can't go onto the stack. So this means you have to pay attention to memory management. And there are like 3 different ways to solve it. The way we would have done it in my exploit development course this semester is we would use return-oriented programming by finding library functions that jump to the stack. And that is an option. But here they mentioned another technique, which I wanted to see, which is when you put something like a string in the gets function, when you pick it up here with gets, it gets is a subroutine, and it reads it into some local variable and puts it on somewhere in memory, and then it gets copied onto your stack frame. So there is a second copy of your exploit in RAM somewhere. And if you can find it, you can use that instead. And I thought that was pretty interesting. So I learned some tricks to find it. And the main thing that got me is you cannot use live GDB. You have to use a stack dump. So let's play with this one. If I do stack 6, and it asks me for some path, and I put in a bunch of junk, I get a seg fault. So something got in an off-I GDB. And let's put this in the clipboard to cause the seg fault. Okay, run that. Okay, it ends up with a 61 here. So I think that means I can control the EIP by just putting in more. If I put in this and then get rid of that and put in A, B, C, D. Oh, okay, say yes. Now put in that junk. Okay, okay. There, okay, so now I control the EIP. But if I try to jump to my shellcode, so I could put shellcode here or I could put it after this, but neither of those is going to do me any good. So let's copy this, and now let's put a breakpoint in. So if I disassemble main, I see that it doesn't really do anything in main. It does it in this function called getPath. All this does is call getPath. So I got to look in there. Okay, getPath prints something, then it gets something. This is where the overflow happens. Then it does stuff, like check and see how big it is. So I can put a breakpoint at getPath plus 43, and that will show me what's going on. Okay, and now if I run it, start from the beginning, put in that junk, and then let's put some X's over here and see what we've now created. If I look at the stack, it goes from 740 to 7A8. So that is here. So I put in the little a's, I put in the A, B, C, D, and then I put in the X's, which are 58. So I can put shellcode here if it's small. I can put it here of almost any size. But all these addresses start with BF. So it's just going to bust me if I try to inject an address like that. I need to find an image somewhere else. So you can do this. You can do info files, and this will show you all the segments of your program, of which there are a lot. That's kind of big and complicated. There's a simple one called info proc map. And let me just make my font a little smaller so this won't wrap as much. This is the one that's a little handier. So let's do this. Okay, there's the info proc map. These are all the memory segments used for it. This is used by the made executable. This is used by C libraries. This is, I don't know what this is used by. So I wonder, right now I have injected code. I've injected a bunch of little a's and a bunch of x's. And I might wonder if that data is in any of these segments, and it is. And you can search segments inside GDB to find them. So let's start by looking on the stack. This is one place where I know it is. So I can search, and it is find, yeah, okay, find from here to here. I hit the wrong, okay, I want to copy this there, and I want to search for AAA. XXXX is what I put in there. There, and it's calling it a symbol, so that's annoying me. It was 58. Okay, so let's use. I think there's a switch for find W1. Okay, /W1 for one word, and then you can put it here in hex. So it is 58. There. Okay. And it didn't find it, which is pretty annoying, and I don't understand why. But anyway, what did I do?
Do you have to do LX? Do you have to do like the hex symbol for each character?
No. A successful one looks like this. So it should have worked, but I'm not going to struggle with that one because the point is we're not going to find another copy of it anywhere because for some reason you can't see it in this memory. What you have to get is a core dump. And so I haven't shown you that before, so that's what I thought would be new today. So in order to get a core dump in Linux, you may remember in Windows, in the advanced computer properties, there's a setting whether you want core dumps or not. And there's even different sizes it can be. In Linux, core dumps are turned off by default, but you can turn them on. And the way you turn them on is by just reserving room for them. There is an environment variable that does that, and here it is, ulimit. Ulimit. You can do ulimit minus C, shows you how much room to store for core dumps. And if you set it to unlimited, it will do it. The point is core dumps are big and they clutter up your machine. So you probably don't want them all the time. But I do want them now. Now, if I run this program, which is what, stack 6 or something? Yeah, it's stack 6. Okay. So now if I run stack 6 and I feed in something that will make it crash, like a whole line of A's. Okay, I'm going to put this in a clipboard for later. Okay, I get a segmentation fault, but I didn't get a core dump. This is another strange annoyance because this is a setuid program. It runs as root. If I were allowed to run it without being root and get a core dump and look at the core dump, I could see stuff that I'm not allowed to see. So it will not execute a core dump when running with elevated privileges from another account. So since I'm not root, I can't do it. But what I can do is I can make a copy of it. I can copy stack 6 to temp stack 6. And now if I do ls minus L of temp, I've got a copy of stack 6 that is no longer a setuid program. Now I own it. Now I can run that. Temp. And now I can put in the path that will make it crash, and now it'll make a core dump. Because I'm not getting secrets I'm not allowed to have. And if you want to find that core dump, it goes in the folder where it came from. So I'm going to do ls minus AL. And it will appear here as one of these cores. These are the ones I made earlier. Here's the one I just made now. So that you see 167,000 bytes. It's the core of this memory, of this machine. So now in there, if you want to analyze a core dump, you do it with GDB. This is all stuff I didn't know. I'd heard about it, but I hadn't done it. That's why I wanted to show it to you. So GDB of temp, you put the name of the executable here, and you put the name of the core dump there, which I better make /temp. This is how you can do static analysis after a crash. We've been doing dynamic analysis where we run the program. This is going to take the crash dump, reload it, and recreate the condition of memory when this machine crashed. This is what happens if you go to Windows. You may remember ever since Windows XP, Windows will crash, it'll pop up a box saying, please tell Microsoft about this problem. there is an option there, if you have paid for a tech support contract with Microsoft, to upload your core dump to Microsoft. And then they do this at Microsoft. They load up exactly what happened on your machine with the crash and can find out exactly why it crashed. And they will do it and analyze it, and then it becomes a knowledge-based article. If you have this driver and this program installed, then you have to put on this special patch. So you can totally analyze. See, now it's telling me it's crashed with AAA and the EIP. It's reconstructed the situation. So now I can do info, proc, map. All right, let me go back to my notes. Some of these things work now. I thought it was info, proc, map. Right? Info files. Right, it's info files now, which gives you a different answer. There, info files now shows you all these load areas, and now you can search them one by one to try to find a copy of the exploit. And remember, my exploit was 58, 58, 58, 58. And it is, there's one up here, someplace in 7F. This stuff is all up near the stack. It won't let me use any of these B7s. But it will, no, the BF. This is the one I can't use, the BF. The BF is the stack. This is the one I can't use. I'm going to find one in here I can use. And so you can just search them one by one, or you can even combine them together. So let's try this. Find W1. So quit here, find /word1. If I notice this goes to 48 to 49, 49 to 4A, and this skips. So I can go from 48 to 4A. That would be the two of these going together. So I had to go from there to there. And I'm going to search for 0x 58. Yeah, 58. There. And it's telling me it was unable to access it, which is pretty rude. And I'm not sure that's right. But let's go up to this one. I think load 9 is the one that works anyway, and see if I can get that to work live. Other than that, it's going to be a pretty bad demo, but such is life. Remember, I couldn't get the last one to work either for some reason. It worked right before class, but I'm doing something wrong now. Here's load 9. I didn't find it, but at least it didn't crash. Let's try the one after it. 200. Okay, some of them it still won't let me access, and I don't really know why. But when you run it live, the one you can't access is the one you need. And when you run this static image, you're able to find it somewhere. I don't know why I'm not having any luck. What is this nonsense? 424? That is pretty messed up. Let's go from 3 to 4 and see if we find it. You know what I'm thinking? Maybe I didn't put in NFXs. Let's try 6161. That's the lowercase a. Yeah, okay. Maybe my live demo is not going to work. The 200 there, 6161. Well, I thought I did lowercase. I don't remember what I did anymore. I've got it in temp. I think I can do run cat temp. What was the name of the thing? Level 6, stack 6, stack 6. Oh, crap. All right. I'm losing my mind. All right, S6 cat. I don't know why I wouldn't cat it before, but I was trying to do it inside that other thing, and somehow I fouled it up. S6, there. Oh, I don't have, the thing I need is not there. Oh, that's from some other thing. All right, I'm losing my mind. Stack 6 is there. I think I just need to make a clean crash dump. That's what I need to do. Let me just run /temp. Okay, let's go to /temp. Okay, I'm going to make one more attempt to try to do this right. There. My crash dumps are here, core.something, core.star. Let's remove them all because I'm tired of them. Okay, now let's do stack 6. And now let's just use a lot of capital A's. I think that's right. There weren't any X's in the actual input. Okay, let's just use a lot of capital A's. Okay, there. Now I should have a core dump. And there it is. Okay. Now I should be able to do GDB of my program, stack 6 on that core dump. Good. And there's the 4141. So now I can do info files. And now I should be able to search some of these things. So if I do, this goes to 97, 97 to 98, 98 to 98. So I can go from 96 to 98, for example. So I can find word 1 from there to 98 and look for 0x 41, 41, 41, 41. Okay, and it's not found, but it didn't tell me anything stupid like I'm not allowed to look there. Now 96 to 97, 97 to 98, and that, okay, so 96 to 98 looks like the next, I did that, okay. Let's try this 5,000. What is this nonsense? FD5 to FD5? 6 to 8, 8 to 9, 9 to C. Okay, so 6 to C looks like a contiguous block of memory. So this to C1000 is another place to look. There to C. Okay, so it's not found up to C, but I think that's all right. I think it is really up here in 9 we're going to find it, which is DE1000 to 2000, then 2000 to 3, then 3 to 4, then 4 to 4. Okay, so DE to 4 is the contiguous block. Okay.
Did we touch products at all in the exploit class?
No, we didn't do them. Some people love doing them and write whole books that way, and I followed a different path that didn't do it that way. So that's why I wanted to bring it up here, because it is worth seeing. E4000. There, let's see what that does. Ha, it's in there. That's what I wanted to see. So we found it. Now, I don't know how to figure out where it is. There's probably some smart way, but I'm content with the stupid way for right now, which is it's not that hard to look, because I have a lot of them to look for. So I can do x/1000 x from here, and I can see them right there. Didn't have to hunt very far. So right there is my injected code. So you can jump to this address and you will find another copy of your input which you can run. So that's kind of cute. And there are 2 other ways to solve this same problem. This is as far as I got. This was the new way. The other way is the old way, which you did cover in exploit development class, which is return-oriented programming. You jump to a library that contains like a jump ESP and trampoline back, so that the actual thing you inject doesn't point to the stack. It points to something, which then goes to the stack. And there are more complicated ways to do it too. But that I thought was pretty cute. You learn how to make a core dump and how to search through a static core dump. So that's all I wanted to show you. Unless you guys have any questions, I'm going to quit. Yeah.
You always set your breakpoint after the first gets.
I set the breakpoint after the overflow. So I look for whatever brings it in. It's usually a gets or string copy or something like that. And if I can't figure out what it is, then I sort of guess and look at the stack.
And you just look at like the functions that are in plain English.
Yeah, just look at the function names you can see to see if you can figure it out. And usually you fuzz. If you can't do anything, you just send in lots of long input with a fuzzer and wait for it to crash. And when it crashes, it tells you where it was. And you can try to work back from there. That's, it can be tough. And most crashes are not exploitable. Most crashes are because it just starts filling memory and it runs out of space and hits the end of a memory segment. And that will cause a crash, but it's not exploitable because nothing you put in ever ended up in EIP or anything useful. You just put in something too big, which used up all the room. So that's a denial of service attack, but it's not possible to turn it into a remote control attack because you never gain control of the EIP. And that's what happened to Ben. Ben fuzzed a bunch of programs upstairs for months or more, and he found a lot of crashes, but none of them were exploitable. There's a Microsoft tool called Exploitable that goes in WinDebug that tells you if a crash is supposedly exploitable. And you can script that too, but we didn't get that far. I saw somebody on Twitter this morning using American Fuzzy Lop. And that is a more advanced fuzzer. It's supposed to be much better. And that would be a good thing to learn how to do. I thought it was kind of daunting, but I should mention it. If you actually want to get somewhere with fuzzers, I mentioned before, I think the simple fuzzers like we use in this class are pretty much useless because I think everybody's found everything you can find with those fuzzers. This seems to be one that people are still using to find new exploits. So it's the American Fuzzy Lop. And this thing, I think, requires you to modify the source code to go with it. I thought it was fairly daunting, and I didn't put it in the projects. But it is another thing that people will use is the Peach Fuzzer. And both of them are pretty complicated, but I think that's what you really have to do to find new vulnerabilities. So maybe in a future course or the next time I teach the exploit development course, which will be next semester, I might try to put in one of these, see how hard this is to set up. That's what it looks like. But this is apparently still working to find new exploits. So we'll see. Doesn't look so bad on his, but this is part 3 of his tutorial. So, you know, there may be something I can add. Yeah. Anything else? There was somebody that connected online. Oh, they went away again. All right, then I won't bother telling them things. You guys got any questions, or shall I stop this thing?
Did
Cam?
you try any of the other VMs from that site exploit?
No, and there's a whole bunch more in this one. So I mean, I'm planning to do a lot more of these. I just did the stack, and there's a bunch other here. Format heap. I thought this whole thing should be like the extra credit for 127, or it'd be a good thing to go through in 140. You know, just go through these and go through the other ones. So I'm thinking this whole series of exploit exercises would pretty much do for 140, or about half of 140. Just going through all these would be good. And that's what I'm planning to do next semester. I'll just have a series of these, and we'll go through them like 3 or 4 every night or whatever it takes so you've seen them all. And then I think you have a pretty good idea what to do for a lot of TTF problems. Yeah, I think that's what it should be. And now I have a pretty good idea. Since there isn't any textbook, this is close enough to a textbook. Some kind of orderly progress. All right, I'm going to stop the share in the video. I can at least post this video because I used a